please make sure that for tomorrow, you should not be later than 9:05 into the class, because we have to just wait that the others should come to the class to start, and it I should say that's a part of the time. Please make sure tomorrow you should not be later than 9:05 maximum. Okay, let's start from this. Okay, today we are going to continue, guys, with the trigonometric identities. By the identities, we mean the inequalities that they are valid for any arguments of the x of that trigonometric ratio. That's essentially what you mean by a trigonometric identities. Any equalities which is valid for any arguments of those trigonometric ratios. That's what you mean by the identities. Now, yesterday we just did two examples. The two examples which we had yesterday, it was for the same concepts, easier one. And today we start by the third example to cover that today. This is, everyone can see that, or there's too much light? Is it good now? Everyone can see it? Hello?
Yes.
Yeah.
Everyone can see that?
Yes.
Awesome. This is sine x minus cosine x squared equals to 1 plus 2 sine minus x cosine x. We try to prove this identity. I give you 2 minutes to just work with that, to just walk around it to see what is that. Then I solve it for you in less than 2 minutes. Then you help me how to do that. Okay, guys, are you done? You need more time? Oh, guys, by the way, I'm going to just tell you something as a surprise. In the next week also, we have a guest speaker. You have no idea who is that going to be. She's you should be surprised by that guest speaker. I'm going to keep it as a surprise for the week after. She's coming from a program which I'm sure you should be very interested to apply to that program.
Oh.
Okay. Are you done, guys?
No.
Not yet? Okay.
Teacher,
Yes.
can you move this a little to left?
Is it good
Yes,
now?
yes, yes.
Okay. Okay. Should I start? Everyone is done now? Ming-Che,
Yes.
Oliver, Brian, Linda.
Yes.
Everyone is done?
Yeah.
Awesome. Okay, guys. Linda, how about you?
Yeah,
Oh,
yes.
great. In order to do that, to make sure that we have done a correct job, guys, what is the first step that you recommend that I should take first? Should I, is it good if I just expand the left side and square it? If that's, it's going to be a kind of a test. I'm going to do that to see how far I can go because it seems that the most reasonable thing. We have to do two things. We have to make two adjustments, one on the left and also one on the right. That's what we are planning to do. It is going to be, I should say, this step, which I'm going to take for the left side of this equation. And when I'm here, I say, okay, for the sine x, minus cosine x squared, I'm going to expand it to see what do I get, which is the left side of the equation. I get sine squared of the x minus 2 sine x cosine x plus cosine squared of the x, correct? That's what I get. And now, look at this. It seems that, guys, when you expand this, please look at the thing which you have done. Look at the thing which you have done at this part. If you come here, take sine x close to the cosine x, which it means that you write it like that, sine squared of the x. You take cosine x squared of the x. You take cosine squared of the x, take it to sit next to sine squared of the x, which becomes cosine squared of the x. Then you are left with that term, which I'm going to write it by a different color, which is minus 2 sine x cosine x, correct? But you remember, guys, from the day before yesterday's session that the sine squared of the x plus cosine squared of the x, it takes you back to identity number 1, which it was the first identity that we just showed and proved it, that the sine squared of any argument plus the cosine squared of the same argument is always equal to what? To 1, huh? Then becomes 1 minus 2 sine x cosine x. Okay, now, then if I distance from the left side, I can simplify this to this expression. That is 1 minus 2 sine cosine x. This is the simplified version of the expression on the left. Now, as long as I'm there, I have to do one thing. I have to compare this result which is this, to the expression which is on the right side. You compare this expression to this expression. These two should be compared. But what's the problem now? The problem is that we have everything looks the same. I have 1 plus 2 sine minus x cosine x, but I have here 1 minus 2 sine x cosine x. And if you say that the problem which exists is the sign, which is I have minus here, but I have plus there. But what needs to be done? Who knows the solution? Mingje?
Yeah.
What is the solution in that case?
I don't know.
I have sine minus x. This is a plus there, and I have a minus there. Who knows the idea, guys? What's the idea which you have from this? Ryan? Linda? Guys, also remember that from I should say from your basic trigonometry in function 11, we said that if this is a Cartesian frame, if I have a unit circle on that, sorry, this is a pen. Maybe you do not see that on the camera. You saw it there, and you suddenly noticed that with this kind of, I should say, calibration, if you decide to have an angle like this, this is gonna be, let's call that x. I make the same thing, but a negative angle, which is gonna be minus x, which is clockwise, becomes minus x, correct? Then you saw that the sine of this angle, which is the projections to the y-axis, they are equal, but because they are on both sides of, I should say, the zero, one of them is gonna be, for example, plus, one of them is gonna be minus. Then as a result, you show that in the function 11 course, that the sine of x should equal to the sine of minus x, but it takes one negative sign, because you can show that also inside, I should say, the unit circle with the Cartesian frame at the center of the circle. Then you see that the sine x is minus sine minus x. Then it means that if you add 1 minus to the argument of the sine function, it's essentially the same thing as the sine of the same argument, but with the minus sign. We call these type of functions odd functions, if you remember it from function 11. Then as a result, this argument which I have there, which is the sine of minus x, should be what? How can I write it? I'm going to rewrite the thing which I have on the right. How to rewrite that? I say 1 plus 2 sine minus x cosine x. then should equal to what? I take minus outside and it comes to the next to the minus 2. Then becomes 1 minus 2 sine x cosine x, which if you compare right now, this one if you compare this one to this expression, expression 2, expression 1, you see that if you compare these two expressions now, they are the same, which it means that you proved this equality, trigonometric equality. Okay, any questions, guys? Everyone is fine?
Yes.
Awesome. Linda, are you fine? Linda? Okay. And now, if you have no questions, we just go to the second example. As we move on, we have more, I should say, challenging examples to come. Okay, now, what's gonna be done right now? Okay, let's do the final one, then we change the topics and move on to something different. The thing which I want you to do, please, is that to prove this identity that we have, that the secant of x is equal to sine squared of the x divided by cosine of the x plus cosine of the x itself. Okay, that's the new identity we have now. Guys, please say your name if you are still there.
Ryan.
Minxin.
Oliver.
Okay, nice. And now, guys, please try this identity. That's almost very easy. Then you have 1 or 2 minutes. Then I join you to just we do that together. Guys, are you done? It's very easy one. Who is done?
I'm done.
Okay, great. Who else? Oliver, Sean, Linda, Brian. Linda, are you done? Linda. Okay, guys, Minje, what is a step that you recommend me to start with?
Change the secant x to 1 over cosine x and equal to sine square x plus cosine square x over cosine x.
Oh, fantastic, fantastic. Thanks. Let me start by this. As Minje said, I'm just gonna, from the right side of this equality, I'm just gonna take what? The cosine x as a common denominator. Then from this, I'm left with the sine squared of the x. And from this, I have cosine squared of the x. Then you see the thing which I have at the numerator, it just rings the bell right away that this expresses which identity, which number? Identity number 1, huh? Then it has to be what? Then it has to be equal to 1 divided by cosine x. But as also Minje said, we know by the definition that the secant of the x is the inverse of what? Inverse of the cosine of the x. Then as a result, you will see that the right side, it exactly matches with the one which I have on the left side. I have 1 over cosine of the x because of the definition of the secant of the x, and I have also 1 over cosine of the x because of the definition which I have as a result of the right side. And then I take the common denominators there. Okay, we just take one more simple example. Now we use all these identities which we show right now for a challenging problem, which I'm just going to give that to you in a couple of seconds. Okay, now in order to do this one, I'm going to also ask you this very simple example, which is necessary for us for the next equation, is that to show that 1 plus tangent squared of the x equals to what? Equals to secant squared of the x. Now we want to show this identity. It's also easy, but we use that for the next problem. Guys, by the way, do you have any questions on the previous exercise which we did? Anyone has a question on the previous one?
No question.
Nope.
No question.
Awesome, thanks. Then please try this one. It's also very simple. You have seen that in function 11. Are you done? Hello? Everybody's done?
Yes.
It was easy, huh?
Yeah.
Awesome. But we need that for the next, I should say, thing which we are going to do. Okay. In order to do that, guys, it's very easy. As you remember from the function 11, what is the first step which needs to be taken? I'm going to start from working on the left, huh? Because the left offers more terms that I can manipulate them. That's right. Okay, what needs to be done? Can I write the left term inside of 1 plus, and for tangent squared, I write what? Sine squared of the x divided by cosine squared of the x, right? Then it equals to what? Take the common denominator as cosine squared of the x, and I have the same thing which is what? Because 1 over cosine squared of the x, which 1 over cosine squared of x essentially what? As secant square of the x. Correct? Any questions, guys?
No.
No.
No? Okay. Now, guys, how many identities we proved so far today? We had this identity, we had this secant identity and secant squared identity, special number 4, number 3, which we did. If you remember, that's one of the most, I should say, identities that you have it in mind. You have to memorize it because it shows up lots of places that 1 plus the squared of an argument is equal to the secant squared of the same argument. Now, assuming that you have seen and you have reviewed these contexts, these examples, I want to give you one task. And that task is going to be very you have to be creative in order to do that. You have to use these identities in order to do what? In order to express, let me see which part of the book is that. You have to be able to express a trigonometric identity in terms of the other, how many ratios did you learn so far? 6 ratios: the sine, cosine, tangent, cotangent, secant, and cosecant. And now the thing we want to do is that we want, and you will have that on your test, that we start with one ratio and we decide to express, for example, the cosine of an argument in terms of the tangent of the same argument. Look, and that's always, which is something which we do. And essentially, we are creating identities. By doing that, you do not have to come to be given an identity, then you have to prove the existence of identity for all arguments of the x. Now you start doing something yourself. You start, for example, by cosine of the x, and now you want to create an identity to relate the cosine of the x in terms of the tangent of the same argument. For example, you are sitting at home, it's raining, you feel so great, you have a cup of coffee, and you think to yourself, how can I express cosine of the x in terms of the tangent of the x? And that's the thing that you ask yourself. Then by asking that question, you are essentially creating an identity. And now, I want to ask you this challenging, I should say, question. Please use these 3 identities, especially the last 2 identities which that you proved. Especially the last 2 identities, please use them in order to answer this question: how a cosine of an argument can be expressed in terms of the tangent of the same argument. And by doing that, you have to come up with an identity. Please do that, and everyone has to just share your result. because you may come with the different answers and I come with my own answer, then we share the results. Please, everyone, do that. I think, what time is it now? It's 9:74. We have still enough time. Please do that, guys. Then we share the results. Remember, the task is that by using the last two identities which we proved today, which they are this, especially this one and this one, to find an identity which relates cosine of the x to the tangent of the x. Okay? Everyone is clear what to do? Nice. Yeah, please start working from cosine. Get yourself to the tangent of that argument. And I think 5 minutes time should be enough. Oh, guys, I forgot to just make, I should say, the unit lesson plan. While you do that, I'm just gonna post it on the website. Guys, are you done? Hello? Anybody's there?
Yeah.
Linda, Brian, Mingji, Oliver, Sean.
Yes.
Are you
Yes.
there?
Yes.
Awesome. Are you done now? Do you need more time?
Yes.
Yeah.
Okay. Okay. Who is done? Hello? Okay, let's do that together. Who got to an answer now? Mingji?
Yeah.
Do you have a result now to share with us?
No.
No worries. How about you, Brian?
Yeah.
Do you have a result to share with us?
Mm, not really.
No problem. How about you,
Um,
Oliver? Oliver? Linda? How about you, Sean?
Yes.
Linda, do you have your result to share with us?
Yes. Oh,
I no answer.
No
Sorry,
worries.
teacher.
We do that together. How about you, Sean?
yes.
What is
The
your answer?
question. What was the question?
The question was that how to connect cosine, find an identity. Actually, you create an identity which connects cosine to the tangent of the x. Particularly, and the purpose was that to use the last identity that we used. Okay, let's do that together, guys. But the reason which we solve this identity, as you have seen that also in function 11, because we were going to use that one for this purpose of that example. What did we have in this identity? Because normally when you plan to just make an identity, you have to find something which is common, a ratio which is common between two other ones. For example, you know that the inverse of the cosine becomes what? You know that the inverse of the cosine of the x becomes secant, that's right. And at the same time, based on the things that we learned before, was that the secant squared of the x, and also we know that the secant squared of the x is equal to what? 1 plus tangent squared of the x, correct? That's what we proved a couple of minutes ago. And now, I'm just going to use these two identities, which we proved before, in order to connect these things together. Okay, what's the best thing to do? I said that I know from this identity that the secant squared of the x equals to what? The tangent squared of the x plus 1. And because secant squared, because secant, guys, everyone is there, please listen very carefully. You may have this one on your test. You have similar things like that coming to your test then please listen very carefully. What's the trick? You see that if you start with this identity, you have the tangent of the x, which you need, because you need to express your cosine with the tangent. And now you have secant squared of the x, which you know that the secant has a cosine inside, because the inverse of the cosine is a secant. Then it seems that that's the best thing to start with, correct? Okay. Now, what do I need to do? I have the secant squared of the x in terms of that one. I take the square root of both sides, then what happens? Then I get the secant of the x should equal to what? Guys, equals to what? Mingje?
Equal to 1 plus tangent x.
Tangent. Now you mean the square root of, inside the square root, 1 plus tangent the x, but also before that plus or minus. Does it make sense to everyone? I'm gonna write it as a note here, guys, as a note to remind you of the things that we did before, and that note is gonna be this. You remembered that, guys, from algebra. I put it as a note that if you have, let's say, for example, a squared equals to, let's say, b, then you know that what? That the a should be equal to plus or minus square root of b. Right? You have to just put plus and minus before the square root of b. And that's the same thing which I did over there. I said that if the secant squared of the x equals to 1 plus tangent squared of the x, I take the square root from both sides, then the secant squared becomes secant of x, it equals to plus or minus square root of 1 plus tangent of the, tangent squared of the x. I keep whatever is there, but put it under the umbrella of the square root. Any questions, guys? Any questions?
No.
And from this, I know what? I know that the secant is what? Secant is 1 over cosine of the x. Correct? Then I know that 1 over cosine of the x equals to the right side of whatever I do have, which is what? Which is 1 plus tangent squared of the x. Also, I don't forget, I have to add plus and minus sign before that the square root, because it's crucial in the algebra. Everyone is doing great over there? Linda, Brian, Mingjae, Oliver,
Yeah.
Sean?
Yes.
Everyone with so much energy says yes.
Yes.
Mhm.
Awesome. No questions so far?
Not really.
Ah, very good. And now, then here I have the cosine. Then what happens there? I'm looking for the cosine to express that in terms of the tangent. I inverse both of them. Then as a result from here, I take everything which from, I flip it, then becomes cosine of the x. Let me write a different color. Then it becomes cosine of the x from here, becomes cosine of the x should equal to what? 1 over square root of plus or minus 1 plus tangent squared of the x, which is page number 3. See, I review that very quickly, guys. Please make sure that you take a note. It may comes up on your test and similar ones. Write the strategy. The purpose which we did today was that we were given the cosine x, the cosine of an argument, and we try to express it in terms of the tangent of the same argument. In order to do that, I use this identity, which we proved that before this, that the secant squared of the x equals to 1 plus tangent squared of the x. Because I know as a trick that the secant has the cosine as an inverse to that. Then that's a good help. Then, because I was looking to express the tangent with the cosine, not the cosine squared, then I take the square root from both sides. Then the secant squared, secant x equals to plus or minus square root of 1 plus tangent squared of the x. Then this is obvious to us at this stage, especially after function 11, that the secant of the x is the inverse of the cosine of the x. Then I simply write for secant, I write 1 plus cosine of the x. Still, I have the right side intact, nothing changes. Now I'm looking to express the cosine, not the 1 over cosine. It means that I inverse both sides of the equality, which I get cosine x equals to 1 over plus or minus square root of 1 plus tangent squared of the x. And by doing that, we are done. Then now, guys, we created an identity. We created an identity. And that identity is this. And that's this identity, that the cosine of the x equals to 1 over plus or minus square root of 1 plus tangent squared of the x. Guys, any questions? Linda, Oliver, Brian, Mingji, Sean, any questions?
No question.
No, not really.
Okay, Linda, how about you?
I need some time.
Yeah, sure. Please take your time, redo that. If you have any question, Linda, please ask me. Okay. But did you make
Okay.
sure that to write everything, Linda? Yes?
Yes.
Great. How about you, Sean? Do you have any questions?
Nope. No.
No. You guys, you know that when you do not have a question, I ask you questions. Please tell me, at this identity which we have, cosine of the x, I have plus or minus of square root of 1 plus tangent squared of the x. Why we have plus or minus? What do you interpret of those ones? That's my question to you all, if you have no questions. We have plus or minus. It seems that we have two branches. It seems that from the cosine of the x, we got two branches of the identity. One goes with the positive number, and one goes with the negative, I should say, argument. Then it's essential there are two identities now. We started to express cosine. That's a very good question. I'm going to ask you now. We just started to write the cosine, but as an identity with respect to the tangent of the x. But now what happened there? The thing which happened there, we have the cosine, But in terms of, I should say, two identities, one identity with the plus, one identity with the minus. What is the difference? Sean, Mingji, Oliver, Brian, Linda. I'm waiting for your answers. Sean?
Oh,
We just looking for one identity, but we ended up with two identities because one is with positive, the other one is with the minus. Why is that so? Why? Is it something wrong? Which of course there is nothing wrong because we use the pure math. But what is our interpretation of it then? Jay? DJ?
Yeah.
Are you there?
Yeah.
What is your answer to this?
You mean the plus and minus sign?
That's right. What do they mean? When do we have to use a positive identity? When do we have to use a negative identity? Brian, Oliver, Linda, Sean. Anybody has an answer to that? Nobody has an answer? Sean? Mingji? Brian? Oliver? Linda? Okay, let me answer the question, guys. It's very crucial and it comes in your test. That, guys, the positive is for the case that your reference angle in the unit circle is moving counterclockwise. It picks the angle which is positive. The negative is for the case that your angle, which defines the cosine of the x is an angle in front of the cosine when it is moving clockwise. Then it groups, I should say, the negative angles. Then in that case, you use the negative sign there. Make sense? Then when to use positive, when to use negative, it depends how your angle is defined as an argument of the cosine. If this is counterclockwise, it's positive. If this is clockwise, this is negative. You got it? Guys, please say your name.
Linda.
Brian.
Minji.
Okay. Did you got the answer for that? Okay, guys, take a break for 15 minutes. It's now time 10:12. We come back by 10:27. Okay.
Okay.
Awesome. Thank you. Hello guys, are you back?
Yes.
Okay, great. Okay, now let's do the very last example for today. What time is it now? Oh, sorry, I was 2 minutes late. Okay, let's go for the last identity. And I'm gonna talk about something which needs to be done. Guys, out of the people here, Sean, did you put your name inside that website?
Yes, yes. I added my name to the science club.
Okay, nice. Uh, okay, let's do the last example. Then I'm gonna talk about, I should say, your assignment, because this weekend you have 2 types of the assignment, and also you have your project deadline coming up with the modeling of the bacterial mitosis. Then seems that you have to work. Okay, guys, any questions about the materials we covered on the first period? Any questions? No? Okay, now. Okay, let's do one identity together. And it's going to be this. We call that the tangent of x, the cosecant of x plus cotangent of the x equals to secant of the x plus 1. Okay, let's prove this identity as the last thing we do today. Then we talk about the plans which we're going to have for the weekend together. Then everyone can see what I have written. Tangent of the x, secant x plus cotangent of the x equals secant of the x plus 1. Okay, guys, please spend 2 minutes on it, then we try that together. Let's see who comes with the answer first.
Mr. Omid,
Yes.
can you read the left side? Read it.
This one,
Left side.
Oh, left, sorry. It seems I forgot English. What is my left? Where is my right? This is tangent of the x,
Yeah.
parenthesis, secant of the x, plus cotangent of the x. You close the parenthesis, then equals to secant of the x plus 1.
Okay, thank you.
No problem. Okay, while you work on it also, I'm gonna make some quick notes of the steps which needs to be taken. And you please continue. And I do some stuff here on my side. Oh my God, I love trigonometry better than anything else. Anyone is done? Who's done, guys? Mingje?
1 second.
Sure. Linda? David? Brian?
I have to say I can't see it really clearly.
Do you see them that you mean the question itself?
Yeah. Oh, it's much better.
Okay, nice. Okay, shall I start or do you need some time? Oh, in the meantime, that you are trying on it, let me take a copy of your assignment posted on the website. Then give me a second. Okay, guys, let's do that together. Who's done? Shall I start?
Okay.
Awesome. Guys, look at that. It was a very, I should say, easy identity because the first thing we should do, that's always what I think. I start from the side of the inequality, from the identity, which is mostly populated with more terms. For example, I have tangent of the x and an expression of the cosecant and the cotangent. Then what do? I come to expand the tangent into each terms there. Then what do I get? I get tangent of the x, cosecant of the x, plus tangent of the x, cotangent of the x. Okay, now what else should I do? Is that I write the tangent, cosecant, and cotangent based on the ratios which they are expressed with. I know that tangent is a sine over cosine, cosecant is 1 over sine, tangent is sine over cosine, and cotangent is cosine over the sine. Okay, what's going to happen now? I can simplify that. I start from the left. Look what's happening there. Look, I have sine x there, and I have sine x there. Can I just simplify that? Can I just cancel them out? I take this sine x, with this sine x. Look at this. I have sine x and sine x there. To the other side, I take them out. Then what I'm left with at the end, I'm left with, on the left side, I have what? I have x equals to 1 cosine of the x plus, I have, look at that. I have also, look at this one also. I have cosine and cosine. These two terms, you can cancel them out. Then what you end with? You end with the right side, you get 1. But what is 1 over cosine of the x? Is 1 is what? Secant of the x, which is plus 1. And that easily the identity is proved now, right? Any questions, guys?
No question.
No questions? Good.
Yeah.
Let me email this. I'm trying to email the homework to you, but let me before we end the class, let me finish the plan. Let me tell you the plan which we have for. Okay. Guys, let me finish this session by reminding you of 2 things. It's going to be page number 4. Let me finish the session by 2 things. Guys, by the way, before we end, I just want to ask you one question. Normally, the other classes which you have, how they use the technology in terms of showing you the contents. For example, do they use PowerPoints? Do they use, for example, light pens? What is the other classes when you have the other courses? Huh?
Art class use PowerPoint sometimes to explain. But other class just nothing interesting to see or more to see.
Oh, they just only talk on the webcam?
Yeah, because for me, there are only 3 class. The rest one is Tahar's class. We are reading novels, so really don't have many things to communicate.
Reading novels. Oh, okay.
Yeah.
Good. Then I hope that this thing which we do was a very good substitute in terms of the fact that we cannot be physically in the class and use, I should say, the whiteboard and the markers. But nonetheless, I'm going to talk about the 2 types of the homework which you're just going to have. Please listen very carefully because you are going to be assessed on it. Guys, you can expect to receive 2 updates. Please check the updates on the school website for 2 things. The first thing, I'm just going to send you one PDF file. The PDF file, I'm trying to post it in 5 minutes. The PDF file is lots of questions about the trigonometric identities. You have until Sunday midnight. Please email to me on the Schoology, as you did with your, I should say, with your assignments. As a Schoology, give me, I should say, email me your the answers, and it should be by Sunday midnight. Only solve even numbers. There are lots of questions. You only do the even numbers, not all of them, just the even numbers. For example, number 4, number 6, number 8, number 10. Do not do them all, just the even numbers. And the second type of the homework which you're going to have, and I hope Linda also, you please make sure that you just go to the updates, Linda, and enroll yourself into the science club. Okay, Linda, I'm just going to give you a kind of a research assignment. The deadline for that is going to be next Sunday. You have more than a week to work on it. I'm going to give you a topic which is going to be a kind of an action potential in the brain, into the cell brain, which is neurons. They call it Huxley, which is actually the equation which governs how the brain works. I'm going to give you that to you as a research. I don't want you to produce the material because they are very advanced, but I want you to do the research on the Wikipedia and some journals to understand how the brain work can be modeled with the math. I don't want you to do any math, just a good understanding. And you have to write it on that Schoology as a blog, all the understanding which you get from it. I put more explanation on the updates, but remember, you have 2 assignments. And also, if you can do more work, if you're good with the programming, Sean,
Yes.
if you are good with programming,
Okay.
this is optional. You can just model that equation in MATLAB or Python or Java and simulate how the brain works. If you do that also, it gives you more mark, but this is not something you have to do. You only write what you understand. But if, for example, some of you are good with programming, you can do that one also, but it's not that homework. But the thing which is expected from you is that you learn what is math in neuroscience and how it helps you. Then at the end, in 2-3 weeks, we have someone, a research scientist from the North York General Hospital, who is going to join us for 20 minutes on the Zoom, that he's going to talk about how the math is going to be relevant as a life science researcher, as a neuroscientist researcher, or in the medicine. Then that's pretty much everything. Then please check your updates before you go to bed tonight. Then I have full instructions on that. Okay. Any questions?
No.
No? Okay. Then I'm just going to assign you 2 homeworks. And also please remember, the deadline for your project is coming so fast. Please keep working, guys. And if you have no questions, I finish the class and I see you all on Monday. Huh? Okay.
Okay.
Awesome. Awesome. If you have no questions, guys, have a very nice day. I see you on Monday, and I again emphasize that please start working early on both of your assignment. As soon as you get the updates, start working on them. Okay?
Okay.
Awesome. If you have no questions, guys, have a very nice day. See you all on Monday.
See you.
Thank
See
you.
you. See
Bye.
you.
Bye.
Thanks. Bye. Bye, everyone.
See you. Goodbye.
Bye, Sean. Bye. Bye, Oliver. Bye, Brian.